Okay, we're going to go through the homework that was given to you on chapter 3 on similarity and congruency. So please take it out. I'll only go through questions that you all need help with. Question 1. No need, can do it. Can? Thought it was a little challenging, but if you all can do it, then okay. So I'm not going through it. 1A. Okay, so 1A. This is going to be recorded, it's going to be uploaded. So if you don't have time to copy down, it's okay. You can go watch the video and copy. Okay, now you're supposed to prove that these two triangles are similar. Whenever you prove that triangles are similar, think about 3 pairs of corresponding angles, whether they are the same or not. So in these two triangles, the first thing that I noticed was that 2 of them, these two triangles, they have the 90 degrees. So that is one angle that is the same already. Okay, so PNS, MQP. Now, I need to find another pair of angles that are similar. If it is too troublesome, I will think about using the ratio of the sides. Unfortunately, in this case, I do not have any information about corresponding sides. So I know guaranteed I cannot use any similarity test that relate to sides, which means that back to square one, I definitely need to prove that 2 pairs of angles are the same. One pair is done already. So let's look at another pair. Suppose I want to check out angle PSN. PSN. Okay, this is the angle. I want to check whether it is the same as another angle. So this is called PSN. Going back to my naming of the triangle, PSN, I want to show that it is the same as MPQ. MPQ. I am now trying to prove that these two yellow angles are the same. Okay. Unfortunately, I don't have any information about the size of these two angles. But if I were to try and write PSN in terms of this angle over here, which is MPS. MPS. Okay, let me just put it down in red. This is my MPS. This yellow angle can be written in terms of this red angle because angles are a triangle. So this yellow one is 180 minus 90 minus MPS. Okay, MPS. Okay, now I have this yellow angle written down as 90 minus MPS. Okay, over here. 90 minus MPS. My objective is to write. My objective is not write MPQ also 90 minus MPS. Is it very obvious that it is also 90 minus MPS now? Yeah. Yes, right. This angle in the rectangle 90 degrees minus this same angle, which is MPS. I get 90 minus MPS. So it turns out these two angles highlighted in yellow are the same. So look at how this was done again. Without information on any other angles, purely by using angle sum of triangles over here, I write this angle in terms of this red angle, which is also related to the other yellow angle with the 90 degrees in one corner of the rectangle. Okay, so whatever the red one is, it doesn't matter, these two yellow will be the same. So now I've proven that 2 pairs of corresponding angles are the same. If 2 pairs of corresponding angles are the same, the third pair must be the same because angles are on triangle. So only for this similarity test, 3 pairs of corresponding angles being the same, I only need to show 2 pieces of evidence. Everything else I need to show 3. Okay, so that is the explanation for part A. Honestly, right, before I explain this, before today's lesson, who didn't know how to do part A? Is that? Didn't know? Then you never ask. You must ask in class. If Lina didn't ask, I'm going to move on. No? Then you'll start wondering why couldn't you do it. Anyway, this was also similar to one of our homework questions. So it's something that I've gone through before, you are expected to have learned it and you must understand it. If during this homework question, if you didn't know how to do it, you must at least remember, hey, I did something similar before. If every lesson teaches something you forget, teach and forget, then how to do well. Okay, so with that, yes. What alternate angles, parallel lines are what? What does what? Oh yeah, can yeah, actually, this is the same as this, right? Yeah, that's that's much easier. Okay, so with that, I'm gonna now quickly show you. I didn't notice it. Okay, we can easily prove that these two angles are the same. Okay, so let me just remove this. Okay, so the change over here is SPN equals to PMQ. So check PMQ, yeah. Alternate angles, parallel lines. Where are the parallel lines? Over here. And then you get the same conclusion again, okay? Okay, so part B, anybody needs to go through? The answer key is given, so you at least know your final answer. Part B, anybody? Part C? If not, question number 2. Question 2A, proving that they are similar. Anybody need help? If not, 2B. 2B, find the length of BC. If not, then 2C. Finding ratio of area, so 1/4. If still no issue, part D, area of trapezium, 36. Anybody needs help? Don't be shy. If you need help, you must say. Otherwise, I just move on. Okay, then question 3. 3A, proving that they are similar. Anybody? No? 3B, 4.5 cm. 3B. Do you need help? Okay, 3C, ratio 4:1. 3D, the YZ value is 4 and 4/11 centimeters. This is exact, no reason to run off. Still no issue. Question 4. 4A. No problems. 4B. 4 cm. 4C, 8 cm. 4D. Yeah? 4D. 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 Okay. Let's go through 4D. Let's see. The area of ADF is 20. Okay. Find area of that BDFG. What did I do this one? Oh, okay. So before that, we knew the ratio of length, which is 1:3. Where did we get that from? Here. In part C, it was mentioned that AC is 4 FC. So when they tell you that AC from A to C is 4 times of FC, you are expected to be able to write down 1 and 3 over here. Agree that? So I am able to find the relationship between this triangle AFB versus ACB also. Okay, so 3, 1. Likewise over here, also 3 and 1. Cancel. Okay, then what I did next was okay. So because over here, FED and GEB, they are also similar triangles, right? And they tell us that this is 4 units, this being 8 units. So this segment is actually half of this segment. So likewise, this must be half of this. Agree? So if this is 3 units, DB is 1 unit, then BE must be 2 units. Agree the bases so far? So now I have this triangle AFD with a base of 3 units, having an area of 20 square centimeters, and another triangle FDE, sharing the same perpendicular height with the same base. That must mean that triangle FDE is also 20 square centimeters in area. Okay, who is lost at this point? All still doing okay, huh? So this area over here being 20 square centimeters is being shared by one small triangle and one larger similar triangle. We knew the ratio of the sides. This big triangle is 3 units from BE versus 2 units, DE versus BE, 3 to 2. So the ratio of the area must be the square of the ratio of the sides, 9 to 4. Okay, so in this triangle over here, the whole triangle is allocated 9 units, whereas the small triangle is allocated 5 units. Sorry, 4 units. 4 units, 5 units, make up total 9 units. Anybody lost over? Who's still following? Following, raise hand. Following, raise hand. Not following, raise hand. Not following. Okay, then I need to rewind. Who understands that area FDE is also 20 cm square? Who understand that part? Raise hand. Understand, raise hand. Don't be shy. Okay, that part understand. Now we focus on this FDE. Okay, FDE versus GBE. You see that these two are similar triangles? Similar, huh? So ratio of area must be the square of the ratio of the sides. We previously already mentioned that this is 1 unit and this is 2 units, or you can use the 4 and 8. Doesn't matter, it is the same ratio. When we square, the simplest one will still be 1 to 2. Okay, big triangle, the side 3 units, small triangle side 2 units. Therefore, ratio of area must be the square. 2 give us 2 square equals to 4. 3 square gives us 9. Section okay? Which are you okay with the entire triangle FDE allocated 9 units for area? You okay with that? And then this part 4 units. Which means that the remaining 5 units must be found in this trapezium. Right? Because 9 minus 4 must be 5. So, given that this is 5 units out of 9 units, and the total is 20 square centimeters, our area of the trapezium must be 5 out of 9 times 20. Okay, over here. Okay, so the first portion was just to prove that those two big triangles they have the same base with the same common height. So their areas must be the same, 20. For C, this 4? Okay, so 4D, anybody see copying? Okay, let your friends finish copying first. Anybody finish this? 4D? Otherwise, I move on. Okay, so Joshua, you wanted 4C, right? AC is equal to 4FC. So do you agree on this part? AF allocated 3 units and FC allocated 1 unit. Okay, then you wanted length of BC. Let me see where BC is. Oh, here. BC, that is the length that we want. It is part of a similar triangle over here, ABC, right? So if I want BC, I will need to use it to divide by DF, which is the corresponding side, which I already have the value. this ratio of the longer side to the shorter side must be the same ratio as the longer side to the shorter side. So that's where we get BC over 5 equals to 4 over 3. So it's not over 5. BC over 6. I saw the wrong number. BC over 6. Lagging. Here. BC over 6. Now DF is 6 equals to 4 over 3. So multiply over, you get 8. 10. Okay, any other questions for question 4? Then we move on to number 5. Okay, 5A. Proving these two triangles are similar. Anybody needs help? 5A. If not, 5B. Answer the. Okay, wait, 5B first, 32 square centimeters. Anybody needs help? Otherwise, 5C. 5C says, find the area of PCS over ABC. PCS, ABC. Okay, so PCS and ABC, they are not similar triangles, right? So when they are not similar triangles, we want to check whether they have the common height. So PCS, ABC, they don't have common height also. Very clearly, one is smaller than the other, and they are not similar. They have common height. Okay, so now our job is to find something that links PCS with ABC. So the link over here is triangle CRB. Let me explain. CRB is similar to PSC, correct? Which means that if I know the area of this smaller triangle, I can find the area of this bigger triangle. At the same time, this CRB, this triangle, is related to triangle ABC. Why? Because they share the same perpendicular height from here down, where AB is the base and RB is also the base. Agree? So now I need to write down my area of RBC in terms of everything else. Okay, so let's start. Let's see my area of BCR, which is set as RBC. This linking triangle divided by ABC is actually 5 over 8 because they share the same perpendicular height. And I believe it was given, yeah, BR 5 units, RA 3 units. So our first step over here is quite easily found. Agree? Same perpendicular height, right? Next. Angle, triangle PCS, which is what they want us to use, versus our linking triangle. Yeah, I skipped a step over there in my working. Now I will probably explain. PCS divided by this linking triangle in terms of the area will be the square of the ratio of the sides. So earlier on, I believe we were given this is 1 unit, this is 4 units, right? So ratio of the area must be 16 over here to 5 square, which is 25. So 16 and 9. Okay. With that information, let me write down. This was originally 5 and 8, right? 5 is BCR. Okay. So this was 5. This was just 3, right? Based on the common height, 5 to 3. Okay, here. This one. Our very first step. For this triangle versus ABC. Section okay? Oh, okay. Okay. Slowly. Our very first step, we said BCR because it is given in the question. BR was 5 units, RA was 3 units. This triangle versus the big one, because they share the same perpendicular height, the ratio of the area must be equal to the ratio of the base. Remember? That's why I write 5 here and 3 here. Okay? At the same time, we're talking about this triangle 4 units in this distance, 5 units over here. They are similar triangles, so the ratio of area must be the square. So 16 over here and 9 over here, total 25. Alright? So now, this linking triangle that I've been talking about, in orange, it is allocated 25 square units. In black color, it is allocated 5 square units. But these two are referring to the same area, right? The 25 units in orange and these 5 units in black, it is actually the same area, right? And because they are ratio, I can change the 5 to become 10. Then the 3 must become 6. I can change the 5 to become 15. Then this one must become 9. Because it is ratio. This orange color is allocated 25 units. I can multiply this by 5 to get the same 25. Likewise, I must multiply this by 5. So if I do that, this becomes 15 and this becomes 25. Now I see that, hey, this area being 25 units, this must be 15 units. At the same time, this being 16, this being 9, this must also be 25. So now the ratio of the area all correct already. Okay, I can use the same color to represent them. This triangle is 16, this part is 9, the whole thing is 25, and this is 15. If I want to find everything, it is 15 plus 9 plus 16, which is 40. So now I have a ratio of, what is it that they wanted? Part C, is it? We're doing part C, right? Yeah, they wanted a ratio of PCS over ABC. So that gives us 16 over total 40. So that's verbally what is happening. Presentation-wise, it is just like that. Yeah, these 2 lines only. Okay, so this was our question 5. Anybody needs more time? Then we move on to 6. Question 6a, proving that they are similar. Anybody? Then 6b, ratio 9 to 14. Anybody needs help? Part B, part 1, the distance QP is 12.6 centimeters. Okay, if not, part 3, the ratio is 5 to 14. Next, part 4, 2.5 cm. Need help, must say, 1.5 cm, part 4. And then part C, part 1, 81 to 196. Part C, part 2, 57.5. Need help, part C, part 2. Okay, let's see what it is. Ratio of my area trapezium, QTSR, okay. We have ratio of PQT versus PRS. Okay, so we need our information from C part 1. So, Zhui, based on part C part 1, area PQT was allocated 81 units, right? The whole triangle was allocated how much? The big triangle. PRS. In your C part 1 answer? Yeah, 196. So the whole thing was 196. So 196 minus 81 must be here, right? Do you agree? And that gives us how much? 196 minus 81, 115. Okay, so far? So can I start? Okay, so can do already, okay. Next one, question 7A. 7A, 20 cm. 7B, 585 square centimeters. Part C, volume 1600 cubic centimeters. Anybody? Question 7. Otherwise, question 8. Jiaxuan, you need help or not? Which part? Say. 7 what? Quick, we have 1 more minute. What did she say? Don't know how to do the whole thing? Okay. So height of port B. Let's start with this part. Height of port B. Definitely it's got to do with the 30 cm. But information that we have is that the base of B, base area of B is 4/9, the base area of A. So if I dot, draw the base, the base area of port B is 4/9 of the base area of port A. So this one is given 4 units, this one is given 9 units. Right? So this drawing over here with the 4 and 9, do you understand what it means? So this base area, 4 units out of 9 units. So now I have the ratio of the area already. Then the ratio of the height must be the square root of ratio of the area. Okay, we'll continue afterwards during our remedial lesson.